Hello, I'm Cherise Clough, and I'm a postdoctoral researcher at the Max Planck Institute for Psycholinguistics in the Netherlands. I want to welcome you to a free and open access course called Foundations in Kinematic Analysis for Multimodal Language Research. This is the first lesson in a lecture series designed to help language researchers learn how to conduct kinematic analysis of hand movement data. In this lecture series, we'll be analyzing videos of speakers producing co-speech gesture, or in other words, producing synchronous hand movements while speaking that convey meaning or emphasis. However, we also hope that these tutorials will be useful for researchers studying sign language. Whether we are studying gestures or signs, the goal is to measure and quantify the temporal and spatial patterns of a movement signal produced by the hands. So, who is this course for? This course is for anyone who's interested in how people use movement to communicate through our visible bodies. We welcome researchers from all kinds of backgrounds who are curious about multimodal language. This field is deeply interdisciplinary and is strengthened by the variety of perspectives and methods that people bring to it. So whether you come from psychology, linguistics, cognitive science, speech pathology, neuropsychology, computer science, or any other area, you're in the right place. Our goal is to make materials accessible and useful to you, and to help you build new skills and make new connections. This course is for you if you're interested in conducting research on multimodal language. In this lecture series, we'll focus mostly on analyzing kinematics of the hands, which is crucial for studying gesture and sign language, but the content is also relevant to researchers studying other communicative signals of the body or movement dynamics. Our goal is to offer a hands-on course providing foundational conceptual knowledge about movement science that guides you through the planning and execution of data collection and data analysis. You don't have to have any prior experience with motion capture or kinematic analysis before starting this course. In terms of reading and writing code, we've tried to make the content as accessible as possible so that even someone with little coding experience can follow the tutorials. We'll be using Python code in the form of Jupyter notebooks, with detailed comments and explanations that make it easy for you to follow. And we'll walk you through the technological requirements for getting started. Finally, if you're curious about more quantitative approaches to describing and analyzing gesture behavior, this course is also for you. We want to provide you with skills and tools that allow you to study gesture in a new way to answer novel research questions. Throughout this course, we'll be converting video data of people gesturing into quantifiable movement traces. Put simply, we're interested in how people move their hands when they communicate. We can study gesture as a long, continuous movement signal, or we can study smaller segments of meaningful movement. For example, many gesture researchers focus on gesture strokes as their unit of analysis. A gesture stroke is defined as the core, meaningful phase of a hand gesture that conveys semantic information or emphasis and is most kinematically salient. Of course, our hands are not the only articulator that we use to produce visual language. Head movements like nodding or head shakes and facial expressions like eyebrow raises and smiles also play an integral role in language. Although it's also very interesting to quantify movement patterns of the head and face, this lecture series will focus on the hands as a starting place for building skills in kinematic analysis. When someone gestures or signs, their hands trace rich, complex movement patterns. Using kinematic analysis, we can calculate the physical properties of a movement from this signal. For example, we can determine where a hand is located at a given moment in time, how far the hand traveled, how fast it moved, and how its speed or direction changes over time. These are ways of turning biological motion into measurable data. These measurements come from the field of biomechanics. Mechanics is a branch of physics that studies the motion of objects and the forces that cause motion. Biomechanics is the study of how our living bodies move and handle forces. The field of biomechanics has a wide variety of applications. For example, improving athletic performance, injury prevention and rehabilitation, and digital animation of characters in movies or video games. Within mechanics, kinetics is the study of the forces and torques that affect movement. For example, muscle activity can be measured during movement using electromyography to help understand how muscles generate and modulate these forces. Kinematics is the description of motion without taking into consideration the external forces. For example, describing position, velocity, acceleration, or angles. Kinematics is the focus of this course. But you might be wondering, what can kinematics teach us about language? We know that language is multimodal. The visible expressions that we produce with our bodies are fundamental to human language. Using kinematic analysis, we can understand the biomechanics of how we structure and produce language with our bodies and how body movements interact with linguistic or cognitive processes. This is certainly not an exhaustive list, but let me give you some examples. With spoken language, we can learn more about how speakers tightly coordinate and synchronize the timing of gestures with speech, and how speakers highlight emphasis or information structure multimodally. We can also study differences in movement kinematics across different groups or populations. This can include developmental changes and cross-linguistic differences. One area of research that I focus on is changes to the coordination and production of multimodal language in clinical populations with brain injury or neurological disease. Language use is very flexible. As language users, we are constantly adapting our language depending on the context. Kinematic analysis can tell us how we adapt gestures or signs under different social or cognitive demands. For example, how do we adapt the timing or spatial properties of our hand movements when describing something complex, when talking in a loud bar, or when interacting with a group of people? Kinematic analysis can also help improve human-computer interaction by helping to create virtual agents that are more human-like in their movements, and who are also able to better interpret human multimodal communication. And finally, both speakers and signers map meaning onto the physical space around them. Studying how language users represent space and motion in language can tell us more about their underlying conceptual representations. There are many exciting potential applications within these areas, and also many more beyond these examples. That is your job as a researcher to identify new and novel applications of kinematic analysis to answer your research questions of interest. The goal of this lecture series is to give you the foundational skills to get started with this kind of analysis yourself. We want to start by acknowledging that there are already a lot of great resources and scripts online for conducting kinematic analysis. One that I especially want to highlight is EnvisionBox. This is an open science platform that hosts a growing library of coding modules and tools for researchers. There you can find tutorials and example code for analyzing multimodal data, including speech, gesture, eye gaze, facial expressions, and head movements. Some of the code that we'll use in this lecture series is adapted from EnvisionBox modules, and it is a fantastic resource. That said, one challenge that many researchers face when learning kinematic analysis is knowing where to start and how to build their skills. This lecture series is designed to give beginners a clear path for building their knowledge and practical skills. You'll learn how to calculate a variety of different kinematic measures. Each lesson combines conceptual lectures, like this one, where we explain the ideas behind each kinematic measure, and hands-on Jupyter Notebook tutorials where we'll walk you through the code used to compute the measures and run the analyses together. You can move through the materials at your own pace and come back to these resources whenever you need to. We also provide a toy dataset so that you can practice performing kinematic analysis on videos that contain lots of gestures and explore how movement patterns differ across speakers. So let me introduce you to the participants that make up our toy dataset. We'll work with a collection of 8 publicly available videos from the YouTube channel of the Moth. If you're not familiar with it, the Moth is a nonprofit organization dedicated to the art and craft of storytelling. They share real stories told by real people through live events and also have a popular podcast. The stories are often funny, touching, and inspiring, and as you can see from these clips, the speakers produce wonderfully expressive gestures. From 8 of these videos, we've created a toy dataset for the course. We'll use video segments that are about 45 seconds long to keep the size of the dataset manageable. And we'll also link to the full YouTube videos in the description below in case you want to hear the complete stories. Along with the video clips, we provide ELAN files for each video that already have gesture strokes annotated. Using these materials, you should be able to reproduce all of the analyses that we show you. And our hope is that you'll then be able to apply these skills to your own datasets. So let's talk about how this lecture series is structured. The lecture series will start with 10 lectures that cover a variety of foundational concepts for kinematic analysis of gesture. The first 3 will be focusing more on theoretical and practical aspects, but from lecture 4 onwards, there will be an accompanying hands-on Jupyter Notebook tutorial. In lecture 2, we'll start with an introduction to motion tracking. What is it? How does it work? And what are the different tools available to collect motion tracking data? Then we'll discuss how to optimize your data collection methods to get the best quality motion tracking data for your analysis. Lecture 4 is the first one accompanied by a Jupyter Notebook tutorial. In this lecture, we'll describe the technological requirements and run you through how to set up your computer to run kinematic analysis and extract motion tracking data for the first time. Once we've extracted our motion tracking data, we'll show you how to pre-process it to reduce artifacts from tracking inaccuracies and enable comparison across participants. After that, we'll show you how to integrate your motion tracking data with ELAN annotations to connect the movement data with timing information about when gesture strokes occurred. In Lecture 7, we'll calculate our first kinematic measure, showing you how to calculate the speed and velocity of a movement signal. In Lecture 8, we'll demonstrate a way to quantify speech-gesture synchrony, examining whether peaks in gesture velocity correspond to peaks in speech loudness. Then in Lecture 9, we'll analyze how a movement signal changes its speed over time to identify gesture submovements and holds. And finally, in our last lecture, we'll show you a few different ways to quantify how participants use space when gesturing, examining the location and size of gesture trajectories. If you're watching this video, then you've already found the first lecture in this series, but you can find all lecture recordings in a playlist on the Multimodal Language Department YouTube channel. The Multimodal Language Department is at the Max Planck Institute for Psycholinguistics in the Netherlands. The department brings together senior investigators, research staff, student researchers, and engineers who use a variety of methods and technologies to study what our bodies reveal about human language. You can learn more about our department and projects by visiting the website, which we'll link to in the description below. The materials for this lecture series are hosted on our department GitHub page. Here you'll have access to everything you need to do the kinematic analyses, but you don't need to worry about how to access these materials until Lecture 4, where we'll tell you how to set up everything to run on your own computer. In the README file, you can see some general information about the course, including how to cite it, the purpose of the course, and a description of the materials. And we've also included an outline of the course for all 10 lectures, where you can find links to each of the YouTube videos, as well as links to the Jupyter Notebook tutorials and lecture slides. Finally, I want to acknowledge the people who have contributed to this lecture series. I'm Cherise Clough. I'll be the instructor of the course and have led the project with help from a great team. Anna Paulman, Monica Kanakanti, Sho Akamine, Ferdinand Parr, Bahar Tarakchu, and Alza Azurik have also contributed in various ways to course conceptualization, initial drafts of materials, and reviewing and editing the final versions. And I want to thank a number of people who have reviewed the lecture materials and provided helpful feedback. This is the conclusion of the first lecture, which has been a general introduction to the course goals, structure, and materials. We are excited for you to follow along and hope that it will be useful for you in your own research. In the next lecture, we'll start with an introduction to motion tracking. In Lecture 2, you'll learn about the principles and technologies behind motion tracking and what the data look like. Thank you for joining, and we'll see you next time.